I'm finally done with this used report. Let me just upload it to the LMS now so I can be. What? File size exceeds the limit of 20 MBs. What do I do now? Oh, wait, yes. Our professor told us that we could zip the files. Let me try that. That should be helpful. Yes, it's done. Only 8 MBs now. But wait, how did it even work? How did it convert my 25 MB report to just an 8 MB file? What magic is this?
That is not
Whoa!
magic, Anya.
Where did you come from? Wait, you know computer science, right?
Yes.
Can you please explain zipping to me?
Of course. And you've just stumbled upon the world of data compression.
Data compression? Sounds complicated.
It is. Well, the super technical version is that zipping often uses algorithms like deflate. Deflate combines a technique called LZ77, which is a sliding window dictionary based approach, with Huffman coding, a form of entropy encoding that uses variable length codes.
Whoa, stop right there. Please, English. You've lost me at deflate.
Fair enough. Let's try that again. Simply put, data compression is all about making files smaller by removing redundancy, basically finding clever ways to say the same thing with less information. And importantly, the way zipping works is lossless.
Lossless? What does that mean?
It means no information is actually lost or thrown away. When you unzip your report, it will be exactly the same as the original, bit for bit. Think of it like packing a suitcase. You're not throwing out clothes, you're just folding them really well to fit more in. Lossy compression, which is used for things like some images or music, does throw away some data to get even smaller sizes, but for documents, zipping is always lossless.
Lossless, yeah, that makes sense now. I definitely need my data. But how does it remove these redundancies?
Great question. Imagine you're writing a report and you use the phrase therefore many times.
Yeah, I'm guilty of that. I probably used that a dozen times in my report.
Exactly. Now instead of writing out that long phrase every single time, what if the first time you wrote it, you put it in a special notebook? Let's call it a dictionary and gave it a short code like #1.
Okay.
Then every other time you needed to write therefore, you would just write #1. Think how much space that would save in your report. The LZ77 part of the deflate algorithm I mentioned does something very similar. It scans through your file, looks for repeated sequences of data, not just words but any chunks of data. It keeps a sliding window of recently seen data to find these repetitions. When it finds a sequence it has seen before within that window, it replaces it with a short pointer saying, go back X characters and copy Y characters from there. It's like creating a custom shorthand for your file on the fly.
That's pretty smart. It's like a find and replace key, is that all?
That's a big part of it, but no, there's another layer using Huffman coding.
Another one?
This one is about how the individual letters, numbers, and even those shorthand codes themselves are stored. Imagine you're sending a secret message using a limited set of symbols. In English, the letter E is super common, while Z or Q are rare, right? Huffman coding is like giving the most common characters very short digital representations, say just 2 or 3 bits. Rare characters like Z get longer digital representations.
So, like, the more common the things are, the less digital space they take?
Exactly. By using shorter codes for more frequent items, the overall size of the file gets even smaller. So Deflate first uses the LZ77 trick to find and replace repeating blocks, and then Huffman coding often comes in to efficiently encode all the resulting pieces.
So, it's a two-step process. First, you find the big repeating chunks and you assign them nicknames. Then, you take all the pieces, including the nicknames, and you assign the most common ones codes.
You've got it. That's the essence of how something like Deflate in a zip file works. It's all about spotting patterns and representing them more efficiently.
So, is that why some zip files shrink down a lot while others don't? Like mine was a text file and it shrank down a lot.
Precisely. And this actually touches upon a really cool theoretical idea from a field called information theory. Files with a lot of repetition, like your text document, are considered to have low entropy or low surprise.
Low surprise meaning they're more predictable.
Exactly. And because it's predictable, there's a lot of redundancy that these compression algorithms can squeeze out. The algorithm can effectively say, this predictable pattern happened again without spelling it all out. This is why your report, full of common phrases and text structures, compresses so well.
So, with high surprise, high entropy, the file size reduces less, but with low surprise, it shrinks more.
You've nailed it. This concept of entropy comes from Claude Shannon, who said that the amount you can losslessly compress data is limited by its entropy. You can't compress truly random data much at all with lossless methods because there are no patterns to exploit. Zipping essentially tries to re-encode your file in a way that gets us closer to its actual information content by stripping out the more predictable stuff.
Wow, that actually makes a lot of sense. So it's not magic, it's just clever algorithms which are really good at finding patterns. And how well they work is based on how predictable my data is.
These algorithms are quite smart, and that's why it takes a few moments for your computer to zip or unzip a large file. It's doing a lot of this pattern matching and recoding based on these principles.
Thank you. Now I can explain it to someone if I'm asked.
You are welcome.